Dubey, representing Vision Valley School, and I'm delighted to present our STEM initiative titled Explore, Experiment and Excel, under the sub-theme Hands-on STEM Learning. Today we walk through how our learners become innovators, developing critical thinking, creativity, and problem-solving skills. We believe this is how our future scientists, engineers, and thinkers are born. So let us dive in the world of STEM. In the 21st century, the rapid advancement in technology, automation, and globalization are reshaping the world with a fast pace. To thrive in this dynamic environment, education systems worldwide are shifting focus towards the interdisciplinary hands-on learning approaches. One such transformative approach is STEM education, an integration of science, technology, engineering, and mathematics. STEM is no longer viewed as a cluster of subjects, but as a framework for transformative education, enabling learners to connect classroom concepts with the real-life application. The initiative Explore, Experiment and Excel was born out of a critical need of transition from traditional passive mode of STEM instruction to the more interactive hands-on approach. Recognizing that students often struggle with the abstract, theoretical concept, and the school sought to create a vibrant exploratory learning environment that uses the real-world material and the practical application. So first of all, let us address the educational challenges. The first is conventional classroom model. Conventional classroom model means the old method which we used to do. Just teacher come, we used to give a lecture and the students are sitting in the 40-30 students those are sitting. So it has several limitations. What are the limitations? The first is student disengagement. All the students at that particular moment, they are not completely engaged. They are present physically but absent mentally. Second is lack of real world application. They don't know that what they are studying, where it is applicable in the real world. Third is low retention rate. And the fourth, obviously the most important one, the minimum skill, practical skill development. There was no skill development in that case. The second one is diverse cognitive ability challenges. See, if in the class of 40 students, if all are studying there, so obviously every student has a different ability. Every student has a different grabbing power. Some can learn very easily, some require more time, some require more extra effort. So in that case, we have to see that every learner is different and so they require the different learning approaches. So here we work on the following objective to achieve a hands-on STEM learning. The three objectives we have focused on: the conceptual enhancement, skill development, and learning transformation. To enhance the conceptual understanding, basically it is through experience, to creating models and the real life application of the concept. Second, the development of the skill. The 21st century skill, we have 4 C's, that is creativity, collaboration, communication and critical thinking. The third one is learning transformation. Basically the previous classes were teacher centered. Now the pattern has changed. Now it is student centric approach. The hands-on practical application is being applied over there. And the inclusive learning approach means the student with a different background, physical abilities or need are all valued. The fourth one is differentiated learning approaches. Differentiated learning approaches means we have to acquire different methodology so that each and every student can grab the concept. So in this segment, we focus on how the mathematical activities were done in the class so that each and every student can learn the concept very easily. So I have taken one example, like the student of class 6 have formed the acute, obtuse and right angle using the yoga postures. So in this they promoted the kinesthetic learning as well as the understanding in the geometrical application become much better. The second example we have seen. the same mathematical activity as 3D pie chart. The student, what they did, they took a different data among themselves. They collected like the sleep, time, their own data, and they plotted them in the 3D pie chart using cardboard and thermocol. So this also, this students track the daily activities. So this they converted the data into fraction and the 3D representative using cardboard. The next we have. This was a small activity just to create the creativity in the, just to check the creativity among the students. So what the teacher did, he gave the A4 sheet to all the 10 to 20 students, 10 to 15 students, and she asked that cut a hole in such a way that a whole body can pass through it in a single thing. So in this, many students tried, but 2-3 students were able to did it. So that was also a way that encouraging students to hypothesize different methods, trying practically the observation, their creativity, their limitation. At the other hand, we have the science and engineering activities. This is being followed from the very lower classes from 5-6 onwards, that what you are studying, you should able to do that. So the first was the physics experiment. Just they require a simple laser light and a cardboard and a plane mirror. And from that concept, before teaching them theoretically, we told them that try to put that laser light on the mirror and see what happens. So in that case, they were able to trace the path of a light ray, and from this concept, we told them that the angle of incidence was equal to angle of reflection, which you are going to study now. Secondly, we have the chemistry applications like the electrolysis and electroplating with the salt water solution. So in that case, students were able to visualize the ionic movement through hands-on experiment. They were able to see the metal deposition process, which is applicable in the industrial approaches as well. The jewelry making and the electronic manufacturing connection. Third, we have the simple fire extinguisher. See, practically we know that what is fire extinguisher, but the students were able to develop that concept. Why doing? They took just simply a vinegar and a baking soda and they reacted it, and they saw the pop-up sound, the CO2 was born, that is the extinguishing the fire. So this was a real world emergency equipment understanding concept. One more side of science and engineering activities where the students were able to make an electromagnetic railway signal using the electromagnetic concept. Here they were created a functioning railway signal using batteries, electromagnet, copper wire and switches. So this basically, it makes them to understand the concept of whatever they are studying in the book, how it is working in the real life. It's a very small concept, but electromagnet, as we know, it's applicable in the real life everywhere, most of the places. The electroscope, as we used to teach the charges in the physics concept. So electroscope, this is done by a simple class 7-8 students, that how the static charge is present. The presence of static charge is being demonstrated by the student. And not only in science, maths and computer, but this technology part is being used in English also. Here, this is an English part which is being, the PPT was made by the students, use of PowerPoint presentation, incorporates technology into the learning process, enhancing the engagement and the presentation skill. So the students are highly excited and amazed to see how the complex concept which they read in the books are easily demonstrated by them and have the widespread industrial application. So now let us outline the teaching method and the learning environment that supports STEM initially. We create a flexible, inclusive learning environment where students learn by doing, questioning and reflecting. So some of the methodologies are, like the first one is hands-on experiment. We are coming to the class, we are teaching, but that is not that every concept will be developed in the student's mind. So in that case, when they will do it practically, so we are acting as a facilitator over there. We are guiding them to do that experiment. We are discussing, the teachers are acting as a discussion and a troubleshooting. Second is inquiry-based learning. Previously what happens, the teacher used to come, they used to give lecture and go. But now the students are smart. They have a curiosity to ask. So they are analyzing the questions over there. They are predicting that if ये नहीं हो सकता, ये होगा तो क्या होगा. this is developing in them. Third, collaborative framework, team-based learning where students brainstorm, design and present solution while integrating multiple disciplines into the cohesive learning models. So collaborative, the group discussion is there. So group discussion, many ideas come from the students' behalf also. Transformed classroom, whatever they are making, they are doing. It has been placed in the classroom so that the students are able to understand, able to it is displayed in the classroom itself. So the further grades, the lower grades, when it is coming to the class, so they are visualizing daily that particular concept. So many of the models, many of the chart papers or the creative things is being displayed in the classroom as well. Some more methods we have except these, like we have documentation. All the students, whatever they are making, they are noting down their observations. Action research method and project based method. It's not every time that we are telling them to make this, if we are telling this, you have to do, you have to think. So they are doing the research and bringing the ideas themselves also. Next we have material use. Whatever we are doing, so first of all we should know that it should be the cost effective so that every student can do it. So maximum project we are taking in such a way that it is affordable to everyone of any background. So here the material use, you can see the plastic bottles, wires, old toys, different many are there which we are using here. So basically we are promoting best out of waste, right? To recycle, we are promoting to recycle the things which are easily available in school or at home, the things which are means cost effective, or we can say that which have minimum purchase, because at least something we need to buy. It is not possible that all the things we can get is very easily. So in that case we are focusing on the minimum purchase as well. Now evidence-based assessment. When this initiative of the STEM was done, the participation of students has increased to 95%. Engagement to 100%, means the backbencher who was not focusing in the lecture class, he also came forward, he came to do that, he also want to do. The curiosity developed in his mind that I can do. Sometimes the backbenchers have more innovative mind than the rectification one. In that case, the performance has enhanced to 30% as well. The students' enthusiasm, the transformations from the passive listener to active participants with a genuine excitement and intrinsic motivation. Now the students are asking themselves, they require more time to do the experiment. Initiated related exploration outside classroom hours, demonstrated sustained interest in learning. The second one is inclusive learning success. Inclusive learning success means the low achieving or the shy students who were not able to ask the questions. He also took part, he also participated and at least learned something rather than nothing. The peer mentoring and guidance provision, reduce the academic pressure and anxiety. The third is skill development. Obviously the creativity and skill development is being done when they are making the models, project or anything. So visual learner benefited from the diagram, models and live demonstration. Auditory learners grasp the concept better through verbal instruction, peer discussion and teacher guided reflections. Kinesthetic learners excelled in physically building, touching and manipulating the materials. As a part of our school STEM initiative under the Explore, Experiment, Excel, the students at Vision Valley School led an innovative project aimed at addressing the real-world challenges through science and technology. So one notable outcome of this approach was the creation of blind-friendly traffic signal. So first of all, I would like to please play the video. I would like to see the video. Let's see the video. Yes. One of the key achievements of the initiative was the way it embedded empathy and accessibility into the technical education, showing students that engineering can and should address the real world social issues. Like you can see here, a physically handicapped person is crossing the road, so it is difficult for him in the traffic to cross the road. So this was innovative idea with using the technology circuit diagram modules of physics which was implemented here, so that when he is coming here, this accelerator is moving and the road is blocked. The success of the project has led to the plans for the further enhancement, including the solar-powered operation, integration, and the mobile app for remote signaling, and the possible collaboration with the municipal authorities for live testing in the urban areas. So this was also selected, I would like to tell you that this project was also selected for the Inspire Award at the state level. Now, inclusivity and equity, very important here. This is focusing on how our 3 E's initiative is covering the learning differentiation, gender equity, and economic inclusion. Like the learning differentiation, we can say the recognizing that each student learn differently. So the program gave every student hands-on opportunity regardless of skill and physically disabled. We included the slow learners by assigning roles situated to their strength, so that if we are making a group, then everyone should participate, like you can see in the second project here. Maintain the gender equity in team roles and leadership tasks. And obviously being cost effective, it included all the economic groups. So sustainability and cost effective, highly applicable into the other schools and can be easily replicated. So, the material we use, as you can see here, this girl has made this reproduction in the plants, the vegetative propagation part. This she used the material, like we can see that whenever we buy a washing machine or TV, तो उसका cardboard आता है नीचे for a base, so that it. So she has used that part and she made this part. This. Secondly, the electrolysis concept, the student has used the pencil, the battery, the plastic bottle which is easily available, and the concept of electrolysis was that he made. So the resource management means the reusable material stored for the multiple grade levels, ensuring maximum utilization and long-term education values. Secondly, the teachers was also learned that how to make them use this such kind of material so that it will be cost effective and it will be easily accessible for all the students. So our faculty learned to design and execute low-cost experiments, reducing the dependency on external kits as well. And of course, it was environment friendly, that most of the things which are used was environment friendly. Avoided chemical waste and promoted upcycling. Now the challenges and their solutions. So first challenges are that varied students' cognitive abilities. So in that, the grouping by ability and peer mentorship. Time constant in regular period. The biggest challenge of teacher is the time management with including their subject, because we have to complete the course as well. The syllabus is also huge in the classes. So in that case, external extra activities is also there. So in that case, what we did, we are dedicating the weekly STEM activity lessons either in once or twice in a week. Lack of resources, in that we are using the waste and household items, and the most important is safety concern. If we are taking a smaller grade children, so safety concern is a very important task for a teacher to keep in mind. So in that case, we have choose the experiment that are age appropriate and to supervise them very closely. So our future scope is to introduce the AI and robotics in the classes with the DIY kits, to build a STEM student-led STEM club for mentoring juniors, to develop the video tutorials and a digital resources hub. So in conclusion, our STEM initiative, Explore, Experiment and Excel, has proven that when students are given opportunity by learning by doing, they transform into thinkers, creators and problem solvers. We bridge the gap between the theory and practice, making education meaningful, engaging and accessible. As we move forward, our goal remains clear: to make the STEM education inclusive, affordable, impactful. So for every learner, because the future belongs to those who explore, experiment and excel. Thank you.